Section 4.3 is on multiplying and dividing radicals. So for multiplying and dividing radicals, we have to use the property we learned in grade 10, which was the square root of two, well, any root for that matter, individual roots multiplied by each other. You can put them both under one radical sign if the two individual roots have the same radical sign. And that property can be extended if there's numbers out front as well, that the numbers here will get multiplied, numbers out front will get multiplied to give you the product of C and D, and then the radical parts will get multiplied to give you the same radical sign of the product of those numbers under the radical sign. So basically when you're multiplying radicals, you have to make sure the indexes are the same for each of the radicals, and then you multiply any numbers out front of the radicals by each other and multiply the numbers underneath the radical signs by each other and put them under that one same radical sign. And then sometimes when you put them together, you might find that the new radical has a perfect square factor, and then you should simplify that if you need to. So let's try a few examples. Whoops. So the first one here is square root of 5 times square root of 2, so they're both square roots, so that means we can put the product of 5 times 2 under the 1 square root sign, and that will give you the square root of 10. And the next one, again, they're both square roots, so unlike addition, they don't have to have the same number under the radical sign. So long as they both have the same radical sign, you can put them under that same radical sign. So 2 and the 4 outside get multiplied first to give you 2 times 4, and then you have 5 times 6 under the radical sign. So that gives you 8 root 30. And you can skip that first step if you want to just go to the last step. That doesn't look much like a 30, does it? Try that again. This pen is hard to write with. Okay, so the next example, again, they're both square roots, so you should be able to multiply them. You only need to check to see that the radical sign is the same when you're multiplying. And then you would multiply the numbers out front, 3 times 4, which would be 12. And the numbers underneath the radical signs get multiplied as 2 times 5, so that gives you 12 root 10. And the next one as well, we have 7 times 2 gets multiplied, and 6 times 3 gets multiplied, so that gives you 14 root 18. Now in this last example, you'll notice that 18 has a perfect square factor, so this is not simplified, because 18, which is under the radical sign, has a perfect square factor of 9. So if you want to write that in simplest radical form, you would have to break down the 18 into its factors of 9 times 2, which then becomes 14 times square root of 9 comes out as a 3, and you're left with root 2, and 14 threes are 42, root 2. Okay, the next ones. Now with these ones here, it might be easier to simplify each individual radical first. And the reason I say that is because sometimes when you put the numbers together, the product together, it becomes a real large number, which then it's kind of hard sometimes to figure out what the largest perfect square factor is. So sometimes it's easier if you break them down first. Now you don't have to do it this way, but usually it's easier to work with smaller numbers. Alright, so we have root 80 has the largest perfect square factor of 16, and 16 times 5 is root 80, or the square root of 16 times 5. And 12 has the largest perfect square factor of 4, so instead of 12 under that radical sign, we're going to have 4 times 3, because 4 times 3 is the same as 12. The square root of 16 is 4, and root 5 is underneath the root sign, and the square root of 4 comes out as 2, leaving you with just 3 under the root sign. So then these two can be multiplied as 4 times 2. The numbers outside get multiplied, and the numbers under the radical sign get multiplied and put under 1 radical sign. And that gives you 8 root 15, which is simplified because 15 doesn't have any other perfect square factors that can come out. So we'll do the same thing with the next one. Break that one down as largest perfect square factor of 32 would be 16. So 16 times 2, and then you multiply root 20, would have the largest perfect square factor of 4. And square root of 16 times 2 becomes 4 root 2, because square root of 16 is 4. And the square root of 4 would come out in the next one as a 2, leaving you with just root 5. So that will give you 4 times 2 and 2 times 5 under the radical sign, or 8 root 10, which again is simplified as much as possible because root 10 does not have any perfect square factors. Alright, so the next one, if we break that one down, is going to be 2 times 9 times 3 under the radical sign. And again, 45 has a perfect square factor of 9, so it would be 9 times 5. So this would be 2 times the square root of 9 comes out as a 3, leaving you with just 3 under the radical sign. Oops, I didn't mean to do that. Square root of 9 comes out as 3, leaving you with just 5 under the radical sign. And that will give you 6 root 3 times 15 root 5, which is going to give you 6 times 15, and then the 3 and the 5 get multiplied under the 1 radical sign, and 6 15s are 90 root 15. And again, 15 has no perfect square factors, so therefore this is in simplest radical form. And the last one here is pretty easy because there's no radicals to multiply. It's just going to be the numbers out front, which is just 24 root 2, which is simplified as root 2 has no perfect square factors. So question 2 now investigates what happens when the two radicals you're multiplying have this exact same radicand and radical sign. So if you were to follow the rules, it's basically this would be 7 times 3 equals the square root of 2 times 2, which becomes 21 root 4. And root 4 can simplify to just simply 2. So basically there's no radical anymore now because it's just 21 times 2, or 42. And if we look at the next one, negative 6 root 5 squared means negative 6 root 5 times negative 6 root 5, which is going to be negative 6 times negative 6, and root 5 times 5, or 36 root 25, which is 36 times 5, and again the radical basically disappears because you're multiplying a radical by itself. You end up with a perfect square under the radical sign, and then once you take the square root of that, obviously there's no square root symbol anymore. So 36 times 5 should be 180, I believe. So basically the last examples show us that the product of two radicals that have the same radicand will be a rational number, which is the same as the radicand. So if you want to put that in kind of symbols, it would be, if you take the square root of a number times itself, you will always get the square root of n squared, which will always simplify to just n. Or more simply, if you just want to write it as the square root of n times the square root of n, and kind of eliminate this step here and just say that will always just be what's under the radical sign. Now they would have to both be square roots for this to happen. If they were cube roots, you'd need 3 of them multiplied by each other to get a perfect cube under the cube root sign. Okay, so before we start the next part of multiplying radicals, you can probably try questions on page 198 of your textbook. Numbers 1 and 4 you should be able to do now on page 198.